for negative exponents, I want you to think about a pattern of powers. We're going to look at increasing powers of 3. So let's say I start with 3 to the first power, and then we're going to look at 3 to the second, and 3 to the third, and we'll stop at 3 to the fourth. So 3 to the first power, you know, is 3. 3 to the second, we know, is 9. 3 to the third is 3 times 3 times 3. And then 3 to the fourth is 3 times 3 times 3 times 3, 81. Now, what you'll notice if you look carefully at these numbers is as we move up each time, we're multiplying by 3. Right? Because 1 times 3, oh, I'm sorry, why do I have a 1 here? Apologies, everyone. 3 to the first is 3. Absolutely 3. Okay, so when I have 3 times 3 gives me 9, and 9 times 3 gives me 27, and 27 times 3 gives me 81, and I could keep going. 81 times 3 is 243, and then I could keep going higher and higher, right, multiplying by 3. But now let's look at what happens if we go backwards. So what happens if we start with the 81 and go to 27? Well, then we'd be dividing by 3, and then dividing by 3, and then dividing by 3. So now if I were to continue this pattern down, and I have 3 to the 0, and 3 to the first, sorry, negative 1, and 3 to the negative 2, and 3 to the negative 3. There is no reason for us to expect any different than the pattern that we've already seen. So we would have to divide by 3 to figure out what 3 to the 0 is. And you probably remember from pre-algebra and algebra 1 that 3 to the 0, anything to the 0 is 1. And that makes sense because 3 divided by 3 is 1. Now we're going to divide by 3 again. 1 divided by 3 is a third. We're going to divide by 3 again. 1/3 divided by 3 is a ninth. We're going to divide by 3 again. 1/9 divided by 3 is 1/27. So we see that negative exponents don't result in negative numbers. But what is happening? I mean, look carefully at what we've got here. 3 to the negative 1 is 1 over 3. 3 to the negative 2 is 1 over 9. 3 to the negative 3 is 1 over 27. So what we have happening is a reciprocal relationship, that when we raise a number to a negative exponent, we're going to get the reciprocal. We're going to get 1 over x to the n. So notice that here the n is negative. When I take the reciprocal, now it's on the bottom and it's positive. So think about reciprocals for a moment because that's what negative means. It means the reciprocal. And if we have, so it's clear that if we had 5 to the negative 2, that would be 1 over 5 to the second, or 1 over 25. But what if we had 1 over 5 to the negative 2? Like, what if it's already on the bottom? Well, it still means reciprocal. Reciprocal, and a simple way to think of the reciprocal is that you would flip it. So that means that this, if I have 1 over 5 to the negative 2, I would take the reciprocal and get this. So when you see negative exponents, it just means that you're taking the reciprocal. So let's try it. 8 to the negative 1/3. So if I take the reciprocal of that, I would get 1 over 8 to the 1/3. And 8 to the 1/3, that means that I'm finding the cube root of 8. And 8 does have an integer cube root, because there is a number raised to the 3rd power that equals 8. So it would look like I'm doing this. And so I gave you a minute there to think about what the cube root of 8 is. Did you come up with it? All right, so you should have gotten 2. So this equals 1/2. All right, let's look at a more complicated case. Here, we have a negative exponent, but remember that just means reciprocal. It means flip. So everything that's raised to the negative exponent that's on the bottom is now going to make its way to the top. So we would have 9x to the 8th raised to the 1/2 over 1. Now we can, since each of these factors inside the parentheses are raised to the 1/2 power, that's the same as saying the square root. So I'm going to put a little 2 right here. Square root of 9x to the 8th. And I can put it over 1, but at this point I don't really need to, because you know that over 1 is the same thing as, just having it written without being in fraction form. So now I want you to think back to what we did before in the previous example. Because remember, if I can get that exponent to match the index, then that means that I can simplify further. Well, I can write 9 as 3 to the 2nd. And the x to the 8th, I can write x to the 2nd, x to the 2nd, x to the 2nd, x to the 2nd. So I can take the square root of all of this, term by term. Square root of 3 squared is just 3. Square root of x squared is x. 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 So I'm left with 3x to the 4th. Now again, if you had to have it in radical form, there's nothing wrong with this answer. But it's best if it says completely simplify, then this answer is completely simplified. Because we took the square root of 9 and we took the square root of x to the 8th.